Up. Does this work? Hey. Welcome everybody for the after lunch session, or one of the after lunch sessions. My name is Tobias Kunze, and this is Christoph, Kassen.
Hey guys.
We're talking today about a number of containers, a number of microservices, large-scale architectures, and our experiences with that. I'm the founder of a small startup out of Silicon Valley where we deal with an operations side of large-scale architectures. And Christoph.
Yeah, I'm a solutions architect for AWS. I'm working as part of the startup team. That's why we're here on this stage. And I've been talking to quite a few of you about microservices and containers. So we figured this is a great topic for today.
Excellent. Yeah. So this is going to be a very simple talk. We're going to talk a little bit about theory. What is it about? You know, what is organic microservice architecture? You may have heard about like evolutionary architectures or these things. It's a little bit different. You're going to see in a little bit. We try to keep this short, and then we're going to report on 2 customer engagements that we've done, where one is a connected car company, the other one is a federal security agency, and talk about real-life architectures. And then afterwards, of course, what are the learnings? What are the important takeaways, right? So fairly simple. And so what is this organic architecture we're talking about? And I want to step back and kind of like box this into the overall ecosystem of what is the business, what is the enterprise doing, and what are we doing on the technology side? Because those should be really complementary. And if you think about it, at the core is always really the agile organization, where everybody wants to be as fast as possible, get to market as quickly as possible. And if you look at this at a high level, it really consists of 2 different things. Number one, these organizations split out, organize in parallel and self-managing teams, right? That gives you this, you know, the maximum speed. And at the same time, also, command and control behavior gets replaced with really rapid decision-making and fast learning cycles. That's what makes an organization agile. Now, often on the technology side, it takes a while for technology to catch up, right? Business is often faster. But what we've seen, or what I think a lot of people see these days, is that with microservices, containers, and all that, it becomes very easy to deploy new things very quickly and connect them up. Value is created on top of and next to existing applications and services. So in a way, applications turn into something that becomes a digital business capability. That is nothing more than a service that has an API. I'm going to provide it, I'm going to provision it, and by definition, I don't know who's going to call it next week, right? It's a central business capability. And what happens then, once I have these business capabilities, is I experience organic federated growth, which means new pieces of applications are being added organically as needed, on an as-needed basis. And that is really the growing service landscape that we're talking about. Very important. It's different from an application. It's different from what almost everybody understands to be a microservice application, because that's typically a standalone, bounded context application. We are talking about connected applications, connected services, and keywords there is often when you hear about somebody's running many applications and shared services. That's the first step into that service landscape, right? Now, last point on this slide is that what is this whole organic about, right? Everybody can be agile, but if you adapt to the needs that either the business imposes on the enterprise, or the enterprise imposes on technology, if you're able to adapt to that, then you become an organic architecture. And the interesting thing is, it's absolutely a mirror image. In the organic enterprise, it's very important, the enterprise is not a machine, right? It's not a military machine or anything like that. It's like, and that's why there are complex emergent behaviors, but very important that leadership knows how to step away, right? And it merely shows direction and then enables action, so teams can actually act on their own. And very similar on the organization, on the architecture side, where again the architecture ceases to be a machine, and it also, it also exhibits complex emergent behaviors. And finally, the operations team shows direction and enables action. Where does that happen? Where can I find myself in that? What does all this lingo mean? And I think the simplest way to look at it from a perspective of operating models. On the left side, the old model, right, where you had model operating on the left side, operating model on the right side, and then supporting layers. The substrate we're all familiar with, bunch of VMs, infrastructure as a service, then moved on into PaaS, managed services, and so forth. Today, we're used to just using pretty much everything, right, in parallel. Middleware, the same thing. It started with integration, maybe ESPs, and so forth. Communication libraries. API gateways, a lot of companies use that to abstract teams from each other, right, to allow teams to call into other teams' applications and so forth. Service mesh, kind of a very focused, narrow concern about how do I connect to that other service. But ultimately, something like a cloud traffic controller that's needed. And that just goes up and up. Operations turns to DevOps. SRE is a topic, it becomes a topic, and it at some point becomes mission critical. It becomes mission control, right? So depending on which of these things you already do, you may kind of locate yourself on that map. But crucially, on the right side is this new operating model that we're talking about in this talk. Now, of course, the question on everybody's mind is, does the stuff exist actually? And yes, it does. But I think one thing we need to all wake up to is that the companies and the technology leaders we've looked up to for a long time are not the good examples here. Very simply because they built their planet scale or web scale dominions at the time where the building blocks were old, right? They typically built it 10 years ago, 15 years ago, with a lot of engineering input, a lot of achievement on the engineering side, but not really something you would do today. And of course, they had to do everything themselves, right? For instance, Airbnb still has the Ruby monolith at the core. There's a bunch of 100 services around it, but there's still the core thing. Netflix, really a fairly simple application. Their problem is scale, right? Pinterest, similarly, Yelp is in the same boat. All these people are, have built these pyramids, amazing engineering feats, but with old technologies. You wouldn't do this today. Now, the interesting thing is that also Amazon Retail is in that same boat, but AWS works differently. And that's something that Christoph can talk to you about.
You already mentioned the building blocks, right? And you might have seen that Lyft announced that they're now all in on AWS, right? And if you look at this slide, this is the pace of innovation, right? So in 2018, so just last year, we launched over 1,800 new services and significant features. And that is on top of the features we launched the year before and that year before. So this is a growing curve, right? And we cannot do this with a static architecture, right? We need to have building blocks ourselves that we can use to enable this pace of innovation, because otherwise we would be stuck with an architecture that is not extendable, where we cannot build new features on top of it. So there you see that we have this kind of organic architecture. It's not something that has been branded that way, but it's all building blocks, internal services being used to build services that you guys can use to solve problems for you, so you don't have to solve them. And this all comes from the retail side, right? So in 2001, we had still this monolithic application powering all the retail stores, and you guys have been shopping like crazy, so we wanted to add new products, new categories, and we figured this is not scalable, right? We have this application, it's not easy anymore to add new stuff to it, and it's also becoming increasingly complex for the teams working on it to add new things, right? And that's why we figured, okay, we need to decompose this application to get this agility back, right? And that's what we did over a course of, well, a couple of years, but it was started in 2002, where we transformed everything into microservices, and we built these 2 pizza teams. And I guess you might have heard the term, but I'd like to point out what that really means, right? I mean, we always say, okay, it's a team that can be fed with 2 American pizzas. That is very easy, right? But you can also think in terms of Scrum team size, right? But it also means that these teams have full ownership, but also full accountability. So both things, they need to go hand in hand, because otherwise something is missing. And if you have these small teams, they can really be focused on innovating. They can improve their service to make it better, to make it easier to operate, to make it more reliable, to make it more scalable, because other teams will depend on their work. They'll be integrating. And then, of course, we're running this in the DevOps model, right? It's a full team. And how does the DevOps model look like? Well, we decompose for agility. I just said that, right? We have the microservices architecture, and we have 2 pizza teams. And then we automate everything. That's at least the goal. We're striving towards it, and that's the standard the teams are measured against, right? Automate everything. We standardize on the tools, and we've released some of them as products as well. So we have an internal tool, and we've turned that into a product which is now called Code Pipeline, for example. And that's just one example. Another one would be QLDB, which was announced at re:Invent. Exists for quite some time internally and has now been turned into a product. So standardized tools, very important. And then we have something which is named belts and suspenders. Others call it guardrails. We have defined some standards, governance, templates that enable teams to rely on a solid foundation and then just build their stuff and ship it to other consumers, customers, whoever is using that. So that is also very important for you guys to come up with a set of guardrails, define those, and then move inside those to all be on the same page, basically. And then last point, and I cannot stress this enough, is use infrastructure as code. Describe your infrastructure as code. Commit it into a repository, do auditing, do code reviews on those, and then roll it out automatically. Don't start by clicking together infrastructure, describe it as code, because otherwise it will be very tricky down the road. But I mean, you might say, well, this is Amazon, yeah, this is this huge company, yeah, this is AWS, but we believe it's not just for the Amazons of this world. It's basically for everybody.
Yeah, and very importantly, so that all the non-pioneers, remember the pyramids from earlier that had to build this themselves, all the normal companies have differentiating factors that are really drivers for these architectures. That starts with like, everybody has heterogeneous environments, right? It's historically grown stuff. It's multiple generations of integrations between applications. I'm not talking about the 10-person startup that has one product and hence one application. Really talking about larger companies, right? In particular, companies that start to really get aggressively into what's called digital transformation, right? Adding more digital services, or aggressively modernizing what they have, where you be it that you're refactoring a monolith into different microservices, or combining new applications built on top of or next to existing things. These connected application shared services, those are the drivers. That is not something that you find in these big pioneer environments, right? That we keep hearing about and keep reading about, right? So also key with the non-pioneer companies is that scale is not a top 3 concern, typically, right? Nobody has a Netflix type scaling demand requirement. What really is much more important, given all the heterogeneity, is agility. Can I get to market fast enough? And that really goes back to the diagram on the first page. But these things drive everybody to move on from, and it sounds silly, most people haven't done microservices yet, move on from microservices to what we call a service landscape. And because that's such an important distinction, I want to illustrate this with an example. So this here is a standard, anybody could have a microservice architecture like this. It's just a schema. You have a bunch of the green things are the application pieces. You have an application, you may have an API on the side talking to some of these microservices, really swim lanes, right? Each of these microservices has their own data stores and so forth. There's an inventing system, there's an admin API from the bottom coming in, ETL pipeline, if you will, bunch of different data stores and SaaS applications. There's a work queue, workers and a message queue on the side. It doesn't really matter. It's a typical, that's how a microservice architecture might look like. But the interesting thing is, if it works, if it's usable, if it's valuable, it takes a month or 3 months till it looks like this, right? And what happened here is you get what we call organic federated growth. New pieces are being added. Some other application reusing a piece of the existing application with some adaptive layering in between, a data access layer there. Bunch of new application type pieces being added, like a gateway. There's another application. We don't even know what it is. Doesn't matter. But very important, because these new pieces, the existing old application shouldn't know about anything about these new pieces being added. There's a bunch of adaptive functionality, adapters and filters and stuff like this being inserted in between. And of course, it doesn't stop here. It continues after that. This is where the microservice architecture starts to become a service landscape, right? Very important distinction. And this is ideal for the business, because once I can operate a service landscape, I have an ideally agile architecture for my business. The downside is that as these things are being added, new loads are being generated and so forth, it's very difficult to control, because I get these complex emergent behaviors at the communication level. So they're all large-scale behaviors, like this image tries to tell you, right, new piece is being added there. That changes the fan-out pattern. All of a sudden, I get general slowness in a different area of the architecture, right? They're real-time. They happen suddenly. They don't build up over weeks necessarily, or some stuff like that. And they're conversation-based. That is a fundamentally new challenge for operations, and that must be managed. So now, that concludes the whole theory, but context-setting part. We're going to talk now a little bit about how does this actually look like in the real world, right? Theory is always abstract. And want to start with an engagement with a multinational car manufacturer, of course, the connected car group within that. And it actually looks very similar in other connected car groups. But what you see here is the problem essentially is you have the car on the right side, right? A bunch of things, head unit, vehicle-to-vehicle communication. It doesn't matter. There's other slides about it. It's a lot of different systems on the car. Some of these need to be pre-aggregated in a MAC fashion, like multi-axis edge computing fashion. So there's the IoT backhaul problem. We are not concerned with that at all. On the client side, there's not 10, not 20, but literally hundreds of applications, internal and external applications, that need access to the car with varying degrees of varying ways of requirements. So the problem, or the piece we want to focus on here, is the connected car support piece in the middle. And the problem that the group had there is that requirements changed so quickly that there's no way for them to architect anything. As soon as I architect something, next week I'm going to discover, oh, I need a totally different channel opened up here to the car, and I need to solder a new wire throughout the architecture. So clearly, that's not something that works. So a diagram here shows you a little bit. You see there's an extra pipeline for managed access. Some applications need specifically managed access to the car. Some of this is more real-time, others can be more intermediated. Other applications only need data to pre-aggregate it, need access to data from the car and so forth. Not important how it looks exactly, but the key things is massively growing set of applications on the left side. An organic architecture in the middle that is growing. This is a massive simplification here, obviously. It's running about like 200 services right now, logical services, and obviously continually growing. Just to give you an idea of how many applications do we have in the connected car scenario, because not everybody is in that world. These are a couple of typical verticals. All external applications, all these logos, you get a sense of how many are there. It affects connectivity, efficiency, mapping, and so forth. Everything down to safety and to the battery. And this is only the standard stuff. It's not even including autonomous driving yet, right? Once you do add that, there's another whole ecosystem of applications that need to talk to the car, or the car needs to talk to from that side. So just to give you an idea how much there's really going on, what this middle piece, this middle layer has to support on a day-to-day basis. Right? So, and Christoph can talk to you a little bit about how this is done on AWS.
Yeah, so we've taken the architecture before, and I've simplified that a bit to give you an idea of how we will build that on AWS. You might recognize quite a few of these service items, right? And we have the car. It might have Greengrass on board so that all the sensor data is aggregated within Greengrass. We can run stuff on Greengrass core and then connect it back to the IoT gateway. And from there on, obviously, we want to have some parts that are streaming data, right? Because we want to be able to see, okay, what's coming in, pre-process the data, make sure we have something like diagnostics and alerting running on top of that stream to see if we have applications, if something is going on with the car. The very central piece of this architecture is something where Dynamo fits very nicely, because it's the car configuration, right? Every car is different, right? You customize your car before you order, and then these manufacturers, they also allow you to unlock additional services, right? So you might buy something which is real-time traffic, or you might buy access to have your smartphone application connect to your car. So every time some application performs an access to the car, we need to check if that action is actually allowed to be performed on the car and enabled, right? So we need to have something in the middle which can have a very high query volume, right? And then we basically have like this access layer, right? And this is just a single computer that I created here, but it is 200, 300 internal applications, services, accessing the car data. And then we've seen in the slides before all these startups that are out there that are trying to build solutions to work with this car data, like fleet management, like where's the car, am I driving properly to be eco-friendly, all these kind of things. They all want to have access to the car. So they're also all connected to this architecture. So we need to make sure that we have a very scalable access layer. We can run this nicely on containers. And then it has access to either the IoT and the car directly, or it just uses data that came in from the car and is stored in a data lake for processing, where we can run analytics on, where we can have BI on top, or we can expose that to other applications. So that was a very simple architecture. And now we want to talk about things that you need to put in place to be able to manage this.
Exactly. So here are a couple of things that we can demo this to you because it's too large, but we're going to have a demo for the second use case. Couple of things that we had to do, what the team asked us to do is they needed a way to, any new deployment, slow it down. Right? Slow it down, meaning like these discontinuities you get when a new deployment comes in, slow it down for a couple minutes or a couple, like 10 minutes. It's essentially quarantining new deployments, whether that's a new development team that gets hooked onto the production system because you can't stage it anymore, or it's a new application that gets deployed, a new application that gets revved, doesn't matter. Everything is by default has had to be quarantined. So that means you need control over the pipes within the deployment at all times, right? Some things had to be segmented out of the gate all the time, like direct access stuff, right? Tamper-proofing systems obviously should be protected. And then the system has different data pipelines, all the different protocol pipelines, so that always had to be like segmented away. And of course, we did stuff like bulkheads to protect against cascading failures, in particular between those protocol pipelines, which had these happen all the time. Couple things also that we did in real time on a continual basis is like really monitor the golden signals between system components for any of these behaviors that we talked about. Like anything that all of a sudden showed up, oh, why is this taking us a little bit slower now? Why is the latency in this part of the overall service landscape a little bit slower? Then what can we do about it? Because it's not about root cause in this case. It's really about can we do about this? Can we do something about this? Remediate this right away, and then tell the team, hey, can you look and diagnose what's going on, right? Filtering of unauthorized requests also it's constant topic, because as we all know, configurations get out of hand, configurations get accidentally messed up. So having another moat around important systems was a big thing, or it still is a big thing. Likewise, being able to exert a little bit of back pressure, right? You get spiky workloads coming in from out of left field. You need to have the ability to just push back ever so gently, so just to smooth it out, so it doesn't overwhelm systems on the right side and so forth, right? So these are like some of the patterns to think about that we had to do in this architecture, in this service landscape. And then...
All right, and on an architecture side from AWS, and let me just go over this real quick, right? We want to have consistent access to data across all services so we can troubleshoot much faster. So what Glassnostic is doing, they're injecting a network component, which is the Glassnostic router, and then I have these channels that I can monitor, and we'll have a demo in a bit to show you how that looks like. But it basically gives me observability within the network. So I can, in this case, I have 2 EKS clusters because I like EKS. And it gives me the capability to do this cluster-wide. I think the more important point is in terms of traffic management, right? You might know, okay, service discovery, retries, circuit breakers, all these kind of things, right? But that is only one part, right? I need to have that for new services, right? There's new connections coming up, new services being added, and most of the time, I will not be able to replicate this environment in a staging fashion, right? So I need to have a way to do staging within my production environment. Bring up a new version of a service or a new service, send a tiny fraction of traffic to that service, take a look at the monitoring, at the logs, see if it's behaving correctly, and then gradually ramp up traffic to that new service, because otherwise I won't be able to test it at all. And from a team perspective, there's always going to be a new client connecting to my service. So I have to work with something that I no longer own, right? So I need these mechanisms for control to be able to deal with that. And that's one of the challenges in this scenario.
Yeah, so the takeaways from this engagement were that these massive amounts of applications that change all the time, the composition of these applications changes all the time, that really created a problem for the architecture group, meaning they cannot design anything up front. They had to resort to something that is essentially a soup of endpoints, right? And anytime you have a soup of endpoints, you end up doing architecture in real time. And once you start thinking about it, it's actually not a weird thing. It's actually much weirder that these days we still do architecture up front, right? We design resilience and failure, resistance up front, which only works up to a certain point. So they realized this very quickly, up to the fact that they installed a new mission control core operations function. They realized at some point the architecture group and the operations group really need to be one group that is essentially like Houston mission control, right? And that would be extremely essential to them to monitor all these complex emergent behaviors, some of which we touched upon, right? Because these things happen in real time. So key learning there for them was that operations really has become a real-time architecture function. And I think a good learning pretty much for everybody there. The second engagement we want to report from is security-oriented. It's a governmental security agency. And this was an engagement around a video conferencing system. Now think about it, you're responsible for all the governmental video conferences, audio conferences, screen shares, chat services, and that's not a WebEx or something like that. It's really a piece of software that is working in that's where each conference is stood up on its own for segmentation. And then, of course, there's a global registry, but there's like authentication involved, there's administration, right? Each conference room is its own, each organizational unit, each department, each governmental unit is its own unit, and so forth. So quite complex, but not unusual setup. If you think about how, for instance, something like Zoom or BlueJeans works, it does exactly work the same way. Each conference is its own set of services because it's all different lengths and it starts at different times. So again, we see like hundreds of different conferences, complex organizational structure, a hierarchy of different departments, and the reason they came to us was that they realized we cannot do that with our existing preventive security model. We have to think in a triangle, if you will, and that includes not just prevention, but also detection and reaction. Because some security events, it's totally okay if I see them happen and I can do something about it, right? The problem is if I can't see that and I can't do anything about it, right? So just again, how this maps onto the AWS structure then.
Yeah. From an AWS perspective, I simplified this a bit, and it's actually quite boring, right? Because we have all the building blocks in place, right? We have things like private link. We have an ALB, which has WebSocket support, so we can run these conferences over the load balancer. We can run all the core services, in this case, mapped to containers for all the tenants. We also have things like CloudTrail and AWS Config, which can monitor the whole setup from the outside. I think the security part, reacting to certain events, to new conferences, that is way more interesting. I think we should take a look at that next.
On the demo. Oh, okay, demo. Let's do it. I think I need to get out of that for a sec. Hold on. Yeah. So I want to show you a couple small things, right? This is the UI of our cloud controller, the traffic controller. And what you see on the left side is the topology, everything that's running. This is being auto-discovered. On the right side, you have something like what we call channels. Those are control points that you can define, predefine, any numbers of them. It's a logical definition. And I'm going to show you how this looks like in a second. But right away, you see what is running. You see like each, or I'm going to tell you now, each of these things here coming in, traffic of participants to a gateway that is a gateway for the video conference, for the conference room. And a bunch of services behind it is chat services, screen share, video, audio relays, right? It's not happening peer-to-peer. And then finally, some of these things are being transcoded and transcribed and stored finally in a metadatabase, in an audio database, in a recording database. So, and there's admin pieces to it. It's not that important. Right away, we're looking right now on golden signals. We're looking at bandwidth right now. We see like a lot of bandwidth being used by this central service here. Hold on. Yeah, this one, you can kind of dig in who's being called by who. But if you want to get a quick sense of like how a certain conference, for instance, performs, you can look at, you can zoom into that piece of traffic and see, is there anything I need to do about it? You see these two participants are pretty easily, nicely balanced. If I swap the perspective, I see, as should be expected, the video relay gets the most bandwidth right now. We're looking at bandwidth, right? I can also keep digging in and correlating these golden signals. I see bandwidth, number of requests and concurrencies are actually correlated. Latency is not, which is a good sign. It's probably below capacity at this point, right? If it wasn't, there would be a negative correlation going on. There's, in terms of security, super important, of course, that these conferences are always, at any time, segmented from each other, meaning like nobody from one conference room can now accidentally behind the gateway sneak into the other conference room. And as we all know, and as I mentioned earlier, misconfigurations happen, things happen, and some things get hacked. So it's important that we can see sometimes that such traffic occurs. And for instance, here's a channel that I created that really, when I say channel, think of it as like a channel on a mixing board, right? It's a logical definition of traffic segments. And here I realize somebody accidentally is talking here from this video relay of the D conference to the H conference. Not something that should happen, right? So at that point, I don't care what it is. Might be a misconfiguration, might be an attack. I don't care. What I'm going to do is I'm completely dialing down that slider at this point, basically prohibiting any further traffic. And we see we had about like 17, 20 requests a second there. Right now, in the last data point, it was 0, right? So now that has been remediated, right? So another interesting point is some conferences are more important, right? If Angela Merkel is in a conference, you don't want anybody to get there, right? And there's a special conference that we set up where it should have a parameter, right? And there's like special authentication requirements. And we see one of these guys here, this guy, is actually also talking to us and shouldn't, because it doesn't belong to this conference. So what I can do at that point is set up a filter. So you can switch on deep packet inspection on the fly, right? And I say, only people who are authorized within the stream for that conference do get access, right? It's an ad hoc DPI filter, right? And then we see that this guy, this participant there, let me switch back to this perspective, is going to stop now. It's this guy here on the bottom there. Yeah. Another thing I wanted to show you is if you look at, often what happens is like DOS attacks, malicious or not, it doesn't matter, right? But for, all of a sudden you see here, wow, there's a bunch of nodes coming up here. These guys here that are really red hot, right? Let me get this one too. And just to get a sense of like the scale of this, right? I'm just looking at the segments where these nodes are clients. I figure out that like, whoa, like 3/4 of all my bandwidth in the entire architecture right now is due to these denial of service attacks, right? So I can quickly go in and say, well, this really clearly shouldn't happen. So what I'm going to do now is I'm going to set a note for myself. Is this looks like a denial of service. Denial of service. This feels like Telnet. Denial of service attack. And what I'm going to do now is some of them may be okay. I'm just going to start with a concurrency limit of 50, which is massively less than what this denial of service actually is, right? So just to give you a little bit of an idea of what can be done once you have control over the pipes in terms of detecting and remediating things, right? And of course, all these pieces have APIs. So somebody could call into the operations group and tell them, hey, there's a new intruder, can you please shut this guy down? Or you can have a security piece, let's say a Sysdig container monitor or whatever, right? Call into the API and tell them, I just discovered something here on this host, please shut all these services down, right? And that makes it a very agile operational system. Cool. I think we can go back to the demo and just recapitulate what happened in this engagement. And it's really, they realized in this agency that the dynamic landscapes they're creating now with containers, with microservices, with connected applications and so forth, need a really three-pronged approach to security. Not just prevention, but also detection and reaction. Also important to them that I alluded a little bit to that in the last example that I mentioned, that you have APIs, that all these pieces, all these tools work with each other, right? Form an ecosystem of tools. And also important that nothing is or wants to be a new platform, right? Who wants to have a new platform that requires investment in terms of like how things are being done? Not at all. It needs to be a tool that can be used and can be taken out again. So segmentation as a service, a key topic for those guys from a security perspective, of course, because dynamic firewalling is really hard. And the interesting piece here, the interesting thought here that I thought I would color in red is that this is actually how SE Linux works, right? If you think about it, you boot up SE Linux, it lives, once it gets booted, it just lives in a world of labels. And now each label can be used to express rules. And that's actually exactly what our engagement did there. So in summary, I think there's three really important things to take home for architects. And that is, number one, in today's world, microservices, containers, service landscapes, and so forth, we need to architect organically. And that means we need to be able to adapt to the changing business needs at all times, right? Very quickly. So that's the first reason why why Agile enterprises start to adopt service landscapes, not just microservices, but service landscapes. Now, service landscapes have the drawback that they exhibit emergent behaviors, complex behaviors, and these need to be managed, right? And key there, of course, is that these organic architectures are really the right architecture for almost all companies. They're not the right architecture for a Netflix, for a Google, for an Airbnb, and so forth, right? Also thinking about continuous modernization. That is another driver for service landscapes, right? A couple years ago, we were still thinking, oh, let's use this managed service, let's use this cloud service, or so forth, and then we're going to use it for 3, 4, 5 years. That's not the right thing to do these days anymore. We live in a world where swapping out components, modernizing components should be a continuous task, right? It should be, the idea of vendor lock-in is a silly idea because switching from one service to another should be an ongoing task anyways. If a new service comes out, I should be utilizing the new service, right? As I get along, as I get around to it, of course. And last, everybody starts now living in a world where you need to be able to control stuff that you don't own, fundamentally you don't own, right? That includes development teams who now start talking to production all the time. You don't have control over what these guys are doing, right? They're not your team. You need to be able to see quickly and react quickly what's going on there. It means deployments. It means different users, freemium users clobbering your premium users, for instance, right? Any other apps in different business units that you depend on, right? Stuff that's something you need to be able to control because maybe you get billed for it, right? Metering needs to be inserted and stuff. Managed services and so forth. So very important, continuous modernization and get control over stuff that you don't own. And that's
it.
That's it.
All right.
If you, awesome.
I hope you got the idea what organic architecture is. We'll be around. Talk to us. Talk to Tobias.
Yeah.
And then go build.
Excellent. Thanks, guys.